When multiplying decimals smaller than 1, it's a little trickier putting it into context for students. So what I like to do is have them think of it as repeated addition to start out with when we get problems like this. And they can tell that 5 times 6 is going to be 30. So they know that 5 times 6 is 30. But that's not 5 times 6 or 6 times 5. That's 6/10 times 5. So one of the first ways I like to point out to them is just to remind them what multiplication is. It's repeated addition. So it's hard to add 5 6/10 times, but they could add 6/10 5 times. So I'll have students try this out, and they'll add it up. And they might start with something like this: 6 plus 6 plus 6. 6 plus 6 is 12, plus 6 is 18. And they carry that 1, they get a 1. Then they can add another 14, carry the 1, they can add one more, and they're going to get 3, or 3 and 0/10. And I point that out to them here that the digits are the same. You still have a 3 and a 0, but where are you going to put that decimal that makes the most sense? Well, here in repeated addition, they know that they're going to put that decimal right there in between, be 3, or 3 and 0/10. From there, from getting past repeated addition, and then I want them to actually try multiplication, what I want students to be able to do is still look at this, but be mindful. Okay, 6 times 5 is 30. That's not a 6, that's 6/10. That is 10 times smaller. So 10 times smaller here is going to make my answer here be 10 times smaller. So what's 10 times smaller than 30? Well, my answer is going to be 3 whole. There you go. So 6/10 times 5, we want to do repeated addition. We can start out that way. Then we can think of, oh, okay, it's actually 10 times smaller, so 10 times smaller than 30 is 3. And then there's also you just want to set it up like this. We could just do the moving the decimals. I can say move the decimal one time. So it's 6 times 5 is 30. Now I need to move the decimal back, so I move this one time, move it back one time. And there's that trick or that skill you can teach them. But I much prefer having them using their number sense, being able to look at this. Okay, 6 times 5 is 30. That's a 6/10. 10 times smaller, it's going to be 3. Moving on. And actually that builds off of their repeated addition as well. Moving on to something like this. Now this is tricky for students. Major common error that I see with something like this is, okay, they get it now. It's going to be a 3 and a 2 in the answer, because 4 times 8 is 32. So I know those digits aren't going to change. It's going to be 32. A lot of the time I have students starting out, okay, so it's going to be 32 hundredths. No, I can't even see them looking at, no. The answer is going to be 3 and 2/10. And 9 times out of 10 starting out, I have a lot of students wanting to say the answer is 3 and 2/10. Because here, repeated addition is impossible. They're not going to add 4/10 8/10 times. They're not going to add 8/10 4/10 times. It's not going to happen. So then they try to just use number sense here, and they're like, okay, 4/10 times 8/10. I know it's going to be 3 and a 2. 3200 sounds too small. Okay, 3 and 2/10. So to work against that, I do a couple things. The first thing I do is just try to build off the number sense here. Okay, what if we just make this, we know 4 times 8 is 32. We then know if I do 4 times 8/10, it's going to make our answer 10 times smaller. That's 3 and 2/10. Okay, I can make it 10 times smaller again here. It's going to be 32 hundredths. And then I have some students here start to see that. Oh, okay, I can see that. It's getting 10 times smaller each time. So we started out with just our rocket math fact here, 32. Then we made it 10 times smaller. Then actually turned it into the problem that we are solving. And it's going to be 32 hundredths. The big aha moment here is when I just turn this into a fraction problem. And I do, okay, we know this is 4/10, so it's 4/10. We know that's 8/10. 8/10. When we multiply fractions, we just go straight across. 4 times 8 is 32. 10 times 10 is 100. That's going to be, in decimal form, 32 hundredths. And that's where kids really go, oh yeah, decimals fractions are the same thing. Of course. It's 32 hundredths. So then they get it. They wrap their brain around that. And if we want to go to this move in decimals thing here, we can go 4 tenths times 8 tenths. I moved it once, moved it twice. So we moved the decimal 2 times, 32. I need to move it back 2 times, 1, 2. We get our answer, 32 hundredths. But that's the last thing I actually show them. I want them to build off of either number sense here, and then I show them this to really solidify it.